In this lecture, we are going to discuss Z transform of some common signals. Now, the first and the foremost signal we are taking is the impulse, unit impulse, that is del n. Now, if we are given xn is equal to del n, now this del n has a property that its value is 1 at n is equal to 0 and it is 0 otherwise. We can see from the graph that the value of del n is equal to 1 at n is equal to 0 and it doesn't have any other value on the axis. Then if we put it in the equation of Z transform, that is xz is equal to sigma n is equal to minus infinity to plus infinity xn into z to the power minus n. Now instead of this xn I can put del n over here. Now this del n, as we have noted that it is valid only for n is equal to 0. So we can put del 0 instead of n into z to the power 0. Now this del 0, value of this del 0 is 1 and z to the power 0 again is 1. So my result or my Z transform will be 1. So the Z transform of del n will be 1. Now talking about the ROC of this Z transform, the ROC will be the entire Z plane. Okay. Now next is the delayed unit impulse. Now this delayed unit impulse, it is represented by del n minus k. Now here we have produced a delay in the unit impulse of k. Now it means that this signal will have a value of 1 only when n will be equal to k. So it is reflected in this graph between del n minus k and n that this value will its value will be 1 only at n is equal to k, and at rest of the places of n it will be 0. So it is mentioned over here in the equation. Now if I put this in the equation, xz is equal to sigma n is equal to minus infinity to plus infinity xn into z to the power minus n. Now if I put in place of xn del n minus k, then as we have seen in the equation above that this is valid only at n is equal to k, so I can put the value of this is equal to 1 only when if I put n is equal to k at z to the power minus n. Instead of z I am going to put k over here. So and then this value will be 1 and at rest of the places it will be 0. So my Z transform will be 1 into z to the power minus k, that is z to the power minus k. Now since this xz is equal to z to the power minus k, my ROC will converge at all the places except at z is equal to 0, because if I put z is equal to 0 in this equation, then it will result into infinity. So my Z transform won't converge. Okay. Now next is unit step function, that is unit step sequence un. Now this un, as we all know, the value is 1 for all n greater than equal to 0. So this is basically a causal signal. Now it will be utilized in various other questions as well, in which un is multiplied with any of the functions. So we are going to witness it for quite a long time, and it is a very important signal which is utilized in signal systems. So un is equal to 1 for n greater than equal to 0 and 0 otherwise. So if I put xz is equal to sigma n is equal to minus infinity to plus infinity xn into z to the power minus n. So since this un is valid for only n greater than equal to 0, then I can change these limits to n is equal to 0 to infinity, and if I change this will result in sigma n is equal to 0 to infinity un into z to the power minus n. Now this un, the value of un in this duration will be 1, so I can put a 1 over here. So this will result in 1 into z to the power minus n. Now if I see this summation, it somehow resembles the infinite GP. So for the infinite GP, I have this relationship that n is equal to 0 to infinity a to the power n, which is equal to a to the power 0 plus a to the power 1 plus a to the power 2 till infinity, will be equal to 1 upon 1 minus a if the value of this mod a is less than 1. Okay, so it in itself is telling us the convergence, that how it is going to converge. So if I put instead of a, if I put z to the power minus n or z to the power minus 1 in this equation, I will be getting xz is equal to 1 upon 1 minus z inverse. Okay, and as I have told you that we are going to put instead of a, z to the power minus 1, so instead of a we can put mod of z to the power minus 1 should be less than 1. So if I take the LCM over here, then xz will result in z upon z minus 1 if mod z is greater than 1. Now this mod z is greater than 1 is nothing but telling about the ROC conditions. Now accordingly, this mod z will be resulting into a unit circle. So here this mod z value is greater than 1, and we have this unit circle. Outside this unit circle we are having this ROC. So as in the properties of our ROC of Z transform, we have seen that for a causal signal the ROC is the entire plane outside the circle. So outside the circle I have this shaded part, and this is resembling my ROC. Okay, so our Z transform will be Z upon Z minus 1, and my ROC will be mod Z greater than 1. Now next we'll look at another signal. Next we'll look at the Z transform of right-handed exponential sequence. Now for the right-handed exponential sequence, we are given alpha to the power n un. Now this alpha to the power n can be considered as an exponential sequence, and since it is multiplied with un, it tells us that our xn will be alpha to the power n for the value n greater than equal to 0, and it will be 0 for n less than 0, since this is multiplied with un. So it will be inheriting the property of un. Now xz, as we know, is n is equal to minus infinity to plus infinity xn into z to the power minus n. So as we have mentioned that xn is equal to alpha to the power n for n greater than equal to 0, so we can change these limits from n is equal to 0 to infinity. So instead of xn we can put alpha to the power n into z to the power minus n. Now taking both inside, and I can take this n common, so I can have alpha z inverse to the power n. Now again, as we have previously seen, that this is somehow correlating to your infinite GP. Now the sum of infinite GP is a to the power n. If I am having from n is equal to 0 to infinity, it yields us 1 upon 1 minus a if the value of mod a is less than 1. So similarly, if instead of a I put alpha z inverse, so my xz will be 1 upon 1 minus alpha z inverse, where the value of mod alpha z inverse is less than 1. So if I take the LCM over here, it will give me z upon z minus alpha, and similarly if I put 1 upon z over here, it will give me mod alpha should be less than mod z, or we can say that this tells us about the ROC, that my mod z should be greater than mod alpha. Now here the radius is of mod alpha. The radius of this circle will be mod alpha, and the ROC will fall outside this value of alpha. Okay, so this is basically the ROC of your right-handed exponential sequence. Next we check the Z transform of left-handed exponential sequence. Now if we check the Z transform of left-handed exponential sequence, now this type of sequence is also considered to be an anti-causal sequence. Now here the signal xn is given to us as minus alpha to the power n u of minus n minus 1. Now this value of u of minus n minus 1 will be equal to 1 for the values of n less than equal to minus 1, and it will be 0 for n greater than equal to 0. Now if I put this in the summation from n is equal to minus infinity to plus infinity xn into z to the power minus n, my this summation will change from n is equal to minus infinity to minus 1. Now since for the other values on the positive side will be 0, I am not going to take them into consideration. So my value will be minus alpha to the power n into z to the power minus n. So now since this is having a limit from minus infinity to minus 1, I can change these limits as well. Now for changing the limit to making them positive, I can use or we can substitute this n to be equal to minus L. Now if I take this L is equal to minus n or n is equal to minus L, if the value is n is equal to minus infinity, then the value of L will be equal to infinity, and when the value of n is equal to minus 1, the value of L will be equal to 1. So my order of summation changes. Accordingly, I can say that L is equal to 1 to infinity. Okay, and since we are changing this order of summation, I have taken this minus common and I have put it outside, and since I have changed this order and I have replaced L with minus n, so this value of n over here will change into minus L. So this minus will multiply with this minus will come inside, and this alpha will be having a power of minus 1, and this power of minus 1 with the z will be multiplied with the power of minus 1 from L, and it will become plus. So my summation will change from this n is equal to minus infinity to minus 1 minus x minus alpha z to the power minus 1 to the power n to xz is equal to minus sigma L is equal to 1 to infinity alpha to the power minus 1 z to the power L. Now it will be easy for us to calculate the Z transform or to find the summation. Now as previously, we can say that this alpha to the power minus 1 into z, I can say that it is having a value of a. Now if I am having a value of L is equal to 1 to infinity a to the power L, it will, if I expand this, it will give me a plus a square plus a cube plus so on. Now if I take a common from this, it will give me a into 1 plus, now I have taken a common from here, so it will give me a. Now from a cube I take 1 common, that is a, then what is will be left will be a square. So here it is, you can see that I have mentioned a, but this won't be a, this will be a square. And similarly I will be having a cube plus a to the power 4 plus a to the power 5 and so on. So this in itself is an infinite GP. Now this value in the bracket can be said to be 1 upon 1 minus a. Now as we have mentioned that this summation of n is equal to 0 to infinity a to the power n is equal to 1 upon 1 minus a. Similarly this value in the bracket will give me 1 upon 1 minus a, where the value of mod a is less than 1. So instead of this a, as we have kept this value alpha inverse z, we can put this value instead of a. So my equation will result in minus alpha inverse z into 1 upon 1 minus alpha inverse z, where this mod of alpha inverse z is less than 1. So after rearranging these values I get minus z upon alpha minus z. Now this minus is outside, I can take it inside, and if I take it in the denominator side, then it will result in z upon z minus alpha. And similarly this modulus will be having this, we will be having 1 upon alpha over here, so this alpha will be going on the right hand side, and then mod of z will be less than mod of alpha with be our ROC. So in the previous example we have seen that in the right hand sequence mod z was greater than alpha, and here the mod z is less than alpha. So the ROC will be consisting of the inside of the circle, which is having a radius of mod alpha. Now this circle over here will be having a radius of mod alpha, and the ROC will be the inner contents of these circle. Okay. Now next type of signals are two-sided exponential signal. Now in two-sided exponential signal we have been given alpha to the power n un plus beta to the power n u of minus n minus 1. Now we have seen individually the left-handed sequence and the right-handed sequence. Now here if we check out the z transform of alpha to the power n un, it will be z upon z minus alpha, where mod z should be greater than mod alpha, and the z transform of beta to the power n u of minus n minus 1 will be minus of z upon z minus beta. Now here we will be saying minus of z upon z minus beta because the previous example we have seen was minus of alpha to the power n u of minus n minus 1. So here there was a negative sign previously, but in this equation over here we haven't mentioned the negative sign outside, so we have to take that into consideration, and my z transform of beta to the power n u of minus n minus 1 will be minus z upon z minus beta if mod z is less than beta. So my entire z transform will be z upon z minus alpha minus z upon z minus beta. Now the ROC, as we can see, were mod z greater than alpha and mod z less than beta. So the ROC will be conforming to these two values and the common point or the common values between these alpha and beta. So my ROC will be mod z greater than alpha and less than beta. So we can see that the outer circle, that is the beta radius, should be greater than the alpha radius. Then only we can get these circular ring, and my ROC will be inside this ring. Okay, this area inside these two circles will be my ROC. Now if my signal does not confirm or my values does not conform to this, suppose that my value of beta is less than alpha, then my Z transform won't exist. Then my Z transform won't exist. Thank you.